Hello, dear students. Today we have the last prop in Book 4, Prop 16 of Book 4, to inscribe a quintagon in a circle, a 15-angle figure in a circle, which is equilateral and equiangular. Okay, come on in. Let's do this here. We know we can inscribe a triangle in a circle that's equal to a given triangle. Let this given triangle be equilateral and equiangular. So let's have that be described in our circle. And we know we can inscribe in a circle an equilateral and equiangular pentagon. So let's have that be done. In the same circle, inscribe that That's not going to be so pretty, but that's okay. We're run out of time. Sorry about that. That should kind of go up there. Oh, that's really ugly. A little bit better. Okay, so let this green figure be our equilateral and equiangular pentagon, and let this red figure be our equilateral and equiangular triangle. Now look, this pentagon cuts off 5 equal circumferences. We've shown that equal chords cut off equal circumferences. Likewise, this triangle cuts off 3 equal circumferences. Okay? So let's get a common way of looking at that. So if this is, do this in green, if this is 1/5, this circumference right here is 1/5, or 1 of 5 circumferences. And this is 1 of 3. This circumference is 1 of 3 equal circumferences. You could also say, let's try to find a common denominator. I could say, well, let this be 3 of, let's see, 1 of 5. So let's get it, we got 15 as our, so let's say this one be 3 of 15, and this one be 5 of 15, 5 of 15. So here you would have 3, 1, 2, 3, and here you would have 5, 1, 2, 3, 4, 5, okay? Then you have 15 in the whole. Great. So this is cutting off 5 equal parts, and this is cutting off 3 equal parts. Okay? Let's subtract these 3 equal parts from these 5 equal parts. Okay? So these are 5 of 15. 1, 2, 3, 4, 5. And these are 3 of 15. All of the same parts, right? Because 15 parts, all those are going to be equal. Good. So what would remain here? 2 equal parts. Here you would have a circumference. Look at this. Boom, boom. This is what cuts off. Here we go. These taken away from these. These are 3 parts. These are remaining of the 5 are 2. So here's 2 parts. Let's bisect this diameter. We know we can do that, given a straight line to bisect, given a part of a circumference to bisect it. Let's bisect this. And after we bisect it, let's fit in parts, okay? So these are equal chords, okay? Now, if we fit this around, we will see that these chords, these will be 15. This is 1 part, 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 15 parts. Okay? Here we have our 15-sided figure, which is equilateral and equiangular. We just proved that it's equiangular, like in the other ways we prove it equiangular. We just, I don't know what we do. Anyway, show it's equiangular. So we take the center, and like we did with the hexagon, maybe we'll make another circle and divide it up and show that the triangles are equal, the sides are equal, etc., and the angles are equal. It's going to be like that. Okay, so we have our 15-sided figure, which is equilateral and equiangular, okay? And that is Prop 16. That proposition could be done better. I think I'm not satisfied with the fact that you see that it's equiangular. But Euclid doesn't mess around with that either. You know, just in the same way as we showed the pentagon and the hexagon can be equiangular, this will be equiangular. And then he says also, by the way, in a corollary here, just as when we made the pentagon, inscribed a pentagon, we also circumscribed a circle about that pentagon, and then we inscribed a circle in that pentagon. In the same way, says Euclid, we can circumscribe a circle about this quintagon, it is 15-sided figure, and then we can inscribe a circle in the same way, he says, in that 15-sided figure, okay? So we have inscribed in a circle a 15-sided figure, which is equiangular and equilateral. And with the corollary, we say we can also take that figure and circumscribe a circle about it and inscribe a circle within it. Thank you so much. Bye-bye.